Hello again, Math 8. This is going to be notes number 29. This is extension 7.4, repeating decimals. We are going to learn how to write repeating decimals as fractions. And I'll be honest, it's really kind of like a weird concept, but once you understand what you're doing, you follow the steps here, it's fairly straightforward. I will show you where most of the confusion happens. And again, please feel free to message me any questions that you have. But once you get the hang of it, this is pretty fun, okay? We're going to deal with or how to write repeating decimals as fractions. And you have written terminating decimals as fractions, like a lot of you know that like 0.5 is the same thing as 1/2, or 0.75 is the same thing as 3/4, 3/4. But because repeating decimals are rational, meaning that they can be written as fractions, you're going to literally be able to write them as fractions, and this is the way to do it. It's a weird way. Please don't ask me who came up with this. I have no idea. I'd have to do that research myself, or you can do that research and let me know. I'd love to find out. We're going to show you how to write repeating decimals as fractions using these steps below, okay? First things first is you're going to set up an equation where x is going to represent the repeating decimal, so what we're trying to convert into a fraction, okay? So I'm going to show you that with example 1. We're going to write 0 and 4/10, but this is 0.4 repeated, meaning it goes on and on and on, 0.44444 as a fraction in simplest form, okay? So first step, write the equation x equals whatever the repeating decimal is. So x equals 0.4 repeated. That's step 1. Step 2, we're going to multiply each side of the equation by 10 to the nth power to form a new equation where n is the number of repeating decimals. So this is where it gets kind of weird. You have to look at how many repeating decimals you have. Here we have 1 repeating decimal, meaning that this is one number that's repeating over and over and over again. So it's 4. There's only 1. So because there's only 1 repeating digit, we're going to multiply each side by 10 to the first power, just one digit, so 10 to the first. Well, 10 to the first means 10, it is just 10. 10 to the first power is 10, okay? So we're going to take that equation. Oh, I realized I didn't write the right colors. That's okay. We're going to multiply by 10 on both sides. Okay, so whatever you do to one side of the equation, you have to do to the other. So I multiply by 10 here, and I multiply by 10 there. So 10 times x is just 10x. 10 times 0.4 repeated. This is where it's kind of weird. You have to understand that when you multiply by a 10, you can just move the decimal place over 1. It's going to be a bigger number. So it's going to be 4.4 repeated. Remember, this is 0.444444. So I know it's not a 0 right here. It's a 4 right here. So 4.4 repeated. Okay, that's going to be kind of weird for some of you, but you have to understand. I just moved the decimal place over 1 time. Okay, and there's 4s on this side. So step 2, done. Step 3, we're going to subtract the original equation. This is the original equation from the new equation. So we're going to subtract this equation, the original, from our new equation. So I'm just going to set it up where x is with x and then the numbers with the number. 10x's minus x. You have 10 and you take away 1. You have 9 x's left over. Okay? Now I'll be honest, this is where I get confused right here. Okay, but you just got to keep in mind, what does this number actually look like? What does this number actually look like? But 4.4 or repeated minus 0.4 repeated is just 4. So the 10s cancel out and you're left with just 4. Okay? If I'm trying to get x by itself, I need to divide by the leech, by the thing that's attached to the x. I want to get x by itself, so the number wants to be with the number, but you got to get rid of it by doing the inverse operation. I have here multiplication. To get rid of multiplication, I have to divide. So I'm dividing by 9 on both sides. So 9 divided by 9 cancels out. That's 1. So I get x, 1x. And then 4/9, just leave it like that. That's what we want. We want it to be a fraction. So x is 4/9. That's our answer, class. Okay? I know, kind of weird. But let's take a look at the second one. And I apologize, guys. There was a mistake in my notes. I think I fixed it in yours. But this should be a negative 0.23 repeated. The 3 is the only thing that's repeating. Okay, not the 2 and the 3, just the 3. So it's 2.33333333 and so on. okay? Step 1, we're going to write this equation, x equals whatever the repeating decimal is, okay, whatever we're working with. We're going to multiply by 10 on both sides, and the reason why, again, is because there's only one number that's repeating. Just one. The 3 is the one that's repeating. So I'm going to multiply by 10 to the first, which is 10. Okay, so 10 times x is 10x, and then we're going to move the decimal place one time. It's going to be negative 2.3 repeating. Okay, it's 10 times this. It's going to be negative. Positive and negative is a negative. I'm going to move the decimal place once to the right. Okay, I think that's going to be the easiest way for a lot of you to think about. Okay, now step 3, we're going to take the original equation and we're going to subtract it from now our new equation. So 10x's take away x is 9x's. Now, again, like I said, this is where I get confused, and to be honest, when I did it myself the first time, I made a mistake here. So we got to make sure that we understand this is negative 2.33333 repeating, okay? So I'm going to put a placeholder here, and the placeholder should not be 0 because, like I said, it's repeating. So this number should actually be 3.3. I'm going to put a little 3 right there so you can see that. 3 take away 3 is 0. Now 3 take away 2 is 1. 2 take away 0 is 2. So it's be negative 2.1. Okay, so the only reason why that works is because this is not a 0 here. This has to be a 3. This is 3 repeating. Okay, so I get 9x equals negative 2.1. Again, to get rid of the number attached to x, I got to divide by 9 on both sides. Divide by that number. So I'm dividing by 9. I get x equals negative 2.1 over 9. Now, because they want it as a fraction, this is not going to be a solid answer for us. And this is one way to go about it. This is how your book goes about it. So I'm going to show you how your book does it. You don't have to do it this way, but it does end up working, okay? I'm going to get rid of this decimal because I don't want a decimal. I want a fraction. The easiest way to do that is going to be to multiply by 10 because I know it's going to cause me to move my decimal place over 1 to the right. Okay, so negative 2.1 times 10 is negative 21. But whatever I do to the top, I'm going to do to the bottom too. So 9 times 10 is 90. Now I have a fraction, but they want a fraction in the simplest form. This is not simplified yet, so I know that they have 3 in common. That's the greatest common factor in both of those. So I'm going to divide by 3 on top. I get negative 7. 90 divided by 3 is 30, because again, whatever I do to the top, I have to do to the bottom. So now, this is my answer. Negative 7 30ths. Negative 7 over 30, or negative 7 divided by 30. They all mean the same thing. Okay, so our original repeating decimal is the same thing as negative 7 30ths. I know, really strange, but it gets better when you keep practicing. Please make sure you're doing your work on Khan Academy too. It's a really good way to practice. Okay, here's the next part of the notes, guys. We're almost done. I have here the answers to these on your own problems, just so you can see if you're on the right track, but I want to see your actual work for each of these. So in your Google Slides, make sure you're posting a picture or actually typing in your work for these. I think it would be easier to post a picture, but if you like typing it in, that's totally fine with me too. Okay, please make sure you're trying number 1, 2, 3, and 4. Okay, let's go ahead and skip to example 3. Okay, example 3, we're going to be writing repeating decimals as a fraction, but this time, class, we have 2 digits instead of 1. Okay, but it's going to be the same process. I'm going to write my equation to equal x, my original repeating decimal too. So we're going to write 1.25 repeated as a mixed number. Notice how they say a mixed number. We don't need to write it as just a fraction. It could be a whole number with a fraction. Okay, so x equals 1.25 repeated, step 1. Step 2, we're going to multiply by 10 to the nth power. But look at here, how many repeating decimals do we have? We don't have 1 anymore, we have 2. Because there's 2 repeating digits, I keep saying decimals. Because there's 2 repeating digits, I'm going to multiply each side by 10 to the second power. Well, 10 to the second power is the same thing as 10 times 10. I think you guys are really good at that. 10 times 10, you know, is 100. Okay, so I'm not going to multiply by 10 now. I'm multiplying by 100 on both sides. Whatever I do to one side, I have to do to the other side of the equation too. Okay, so 100 times x is 100x. Now, because I have 100, I can move my decimal place over twice, not once. There's 2 zeros. So I can move over 1, 2. So I get 125. Okay? 0.25 repeated. Now notice how I didn't just put 125. I wanted to show the decimal portion of it too, because this isn't just 1.25. It's 1.252525252525 and so on. So I want to make sure I have that repeating decimal expressed. So it's 125.25 repeated. Okay, you got to make sure you keep that repeated portion of it. Now, I'm going to take my original equation and subtract it from my new one. That's step 3. 100 x's, take away 1 x is 99 x's. Okay? 125.25, I subtract 1.25 repeated. This and this is going to cancel. I have 125 minus 1, which is 124. Now just divide by 99 on both sides. And this is my fraction. They said they wanted it as a mixed number, so I just made it into a mixed number. I divided, and I know that 99 goes to 124 one time, and there was a remainder of 25. Okay, so you can use your calculator for that, or just do your work off to the side. Okay, and that's pretty much it, class. Make sure, again, you're doing the other 2 on your own practice problems here. So number 1 and 2, I have the answers here so you can see if you're on the right track. Okay, so getting the answer shouldn't be or showing me the answer shouldn't be the problem. What I want to see is your work. Okay, please make sure you post your work onto the Google Slides. All right, let me know if you have any questions, class. If these, again, like I said, if they're working, I'll continue to do them, because I know some of you like to see how I explain some of the textbook. Okay, all right, class. See you later.